Welcome, everyone. Just to start off, I would like to take a pulse of the audience. How many of you here are already running EMR in production? Show of hands. That's a good set. How many of you are in the process of migrating to EMR? That's a good chunk as well. So I'm guessing whoever didn't raise their hands, they are exploring moving into EMR, and I'm interested in understanding what that means. So my name is Sandeep, and I'm here with my colleague, Giri Raj. He goes by Giri. He'll come out next. We are from the Intoit Small Business Group. 6 months back, we completed moving to EMR, and the goal of this talk is to share the journey that we went through with the goal of sharing the patterns so that I can help you with your own journey as well. It's a jam-packed 60 minutes. We have some demos lined up as well. So in case we run out of time, we'll be hanging around for questions after the talk as well. Now, this slide is not an eye test. What this slide represents is the complexity of our pipelines. What you're basically seeing are job dependencies that exist in running our day-to-day business-critical dashboards, as well as use cases that serve in-product experiences. This pipeline, or these pipelines, are a sizable scale that are critical across the board, both from business processes as well as for the product. As well as it has a sizable set of users. We have 600 plus data analysts and data scientists using this platform across multiple use cases. Hopefully this gives you a sense of what our platform look like on-prem. And with that, I want to sort of introduce what this talk is all about. So in this talk, we are going to walk through our journey in terms of how do we take a platform at that scale and move it to EMR, right? So the journey essentially is we start off by what are the motivations of the migration, how did we go about with the considerations and the key strategy to make migration happen. Then you'll see demo in terms of some of the tools we had to develop as a part of streamlining the deployment and operationalization. We'll come back with a scorecard with 6 months where we stand and what the next steps are. So very briefly, just to orient you in terms of our business use cases, I want to introduce Intoit. How many of you have heard about Intoit? Awesome. I think that's pretty, almost the whole room. Intoit is a financial software company. You may know us for products such as QuickBooks, TurboTax, Mint, ProTax, ProConnect. They're all Intoit products. I refer to Intoit as a 36-year-old startup with respect to the agility with which we move. And our mission is powering the prosperity across the world. The centerpiece of our strategy is really an AI-driven platform. And as you can imagine, data is absolutely critical for any of these. So wanted to set the context as to how important data is for the business use cases and the features in the product that we implement. So with that background, I first want to start off by what did our on-prem architecture look like, right? I talked about the scale. Now I'm going to sort of give you a little bit more sense on the deployment. So from the data sources standpoint, we have thousands of data sources. Think of these as database instances, Kafka streams, different file formats, you name it. Roughly, our data sources have 4 buckets, just from an orientation standpoint. There is user-entered data, that is the data that customers are inputting in the product. There is behavioral data, clickstream, et cetera. There is CRM/billing, customer relationship management, all the information we gather as a part of that. And the last bucket is third party, including social feeds. All this data gets ingested, both in a combination of batch and real time, into the lake. And on-prem, the lake essentially is HDFS. Now, with that data in place, there is analytics. This is a combination of Hive, Spark, and a lot of data warehousing. So when you think of our jobs, it's really this mix of analytical jobs that are run. And essentially, this becomes the input to multiple reporting systems. So that's the general, I would say, high-level view of what our architecture on-prem look like. Now, with this, the very first question is, why migrate? What was the motivation to migration? Some of the pieces are obvious. We were growing at a very high phenomenal rate in terms of the amount of data and the amount of processing, the number of use cases, the number of capabilities we're building in the product, and essentially running out of hardware, both in terms of compute and storage. And this was really impacting our business with respect to job failures, delayed dashboards, which was quite significant. I think the other aspect also is just the scaling of operations. Think about patching. Think about all the security updates. Think about the 24/7 support of the entire hardware-software stack. It became very clear to us that if we want to scale at the rate at which we were, we needed a different strategy. The current strategy of being on-prem and adding hardware is essentially not going to cut it. So that was really our motivation. And as a next part in the journey, it was all about how do we now take the current state and think about all the different considerations we need to account for from a migration standpoint. At this point, I'll call my colleague Giri, who will continue with the journey.
Good afternoon, everyone. In this part of section, we're going to talk about our journey map and do a deep dive on some of the key migration considerations. To kickstart, here is a journey map. We initiated our journey of November of last year, and by May of 2019, we were fully operating in AWS EMR. Our first step was evaluate the options. Shall we go on Hadoop on EC2 or use AWS EMR? Since EMR is a managed services, we can provision easily the clusters, transient clusters. Hence, we decide to move on to EMR. The next step was sandbox testing. How does a platform perform compared to our on-prem? For this, we had a sandbox testing. We ensured all the security measures taking care of it. With that, we moved on to creating a platform, which means thinking about capacity management, performance, operational monitoring, the entire 9 yards. Once a platform is created, we onboarded users to the platform, migrated all the ETL jobs to the platform, and then finally decommissioned the existing on-prem hardware and moved on to onboard new services like Athena, QuickSight. Now, looking at the entire scope of migration, we segregated our workloads into 4 major buckets. Number 1, the long-running ETL. These are SLA bound, which generates critical business reports. Number 2, the interacting query, which are run by users on a secured environment. Number 3, the third-party vendors data, which we do transformations. And lastly, the analytical scripts. Segregating these 4 buckets into 2 major buckets of EMR. Persistent EMR, which are long range, and the transit EMR, whereby we create a EMR, run their job, and terminate the EMR. Now, next step in our journey was to determine the sizing of our EMRs. In Hadoop, we have one big infrastructure. How many EMRs sizing we are supposed to create? For which we created a shadow testing framework. The intent of shadow testing framework was to simulate the traffic which is running on on-prem and run it on EMR. The goal was identify the instance type for each of the EMR. What should be the auto-scaling policies we are supposed to use? Concurrency, how the EMR will perform when the load is being concurrent. Finally, which is most important, is cost. How much a cost of the EMR will be spending. The top right indicates the number of sprints it took to develop this framework. So the way we developed this framework was, we took a subset of queries, which are small queries, and the queries which are long. Anytime which is query which is more than 5 minutes to an hour are long queries. And we ran those queries on our Hadoop infrastructure. Then we wrote a Spark job to process the data and segregate it by users and time it took to run the query, which finally, via Cloud Sync job, be pushed to an S3 bucket. So based on users, we knew these users correspond to how many EMRs. We created n number of EMRs based on our business users and ran those queries on those EMRs. Results, we finally published into another S3 bucket. So we had two S3 buckets. One, the data from Hadoop. Second, the data from EMR. We ran this multiple number of times till our performance is on par or better than on-prem by changing instance type, by changing query parameters. Here are the results of our details for our queries, which are small queries. The blue indicates the on-prem, the red indicates without tuning, EMR cluster, and the green indicates after the cluster is in tuned. We can see that our performance is better than on-prem. Similarly, here are the results of the mixed queries, which are also very promising. Now with that, our next stop of our journey was, great, how do we create platform? In this present part of section, I'm going to go deep on the data lake architecture and talk about some of the use cases of our EMR. Talking about our AWS data lake architecture. At the 50,000 level up, we have n number of sources, we have n number of AWS accounts, and n number of database sources. All those get ingested into a S3 by ingestion frameworks. This all is in a Parquet format. Similarly, the behavioral data and the clickstream data get ingested into the S3 raw data layer. The data can be structured, semi-structured, or unstructured. Here, we have EMRs which are running. We have n number of EMRs. The data mart EMRs process the ETLs. Similarly, we have multiple business unit EMRs which process the Spark jobs. And the results are published into another S3 bucket. We use Hive Metastore, which have information about all the metadata. This entire process is monitored end to end, and we have a data incident management process in place which triggers in case any of the jobs miss in the SLA. Doing deep EMR use case. So the first EMR use case are persistent EMR use case, which are used for scheduled pipelines. We have n number of these EMRs. The user can trigger a job using scheduler UI. The scheduler UI communicates via to all the EC2 instance to the agents via load balancer. The developers checking the code via Git, and with the Git sync process, this agents gets the latest code. We have the EMRs there. The agents run the step function to run a job, or we can call a Hive query via beeline. The results get persisted into the S3 bucket. Each of the EMR have access to individual S3 bucket. They can read from all the corresponding S3 bucket, but they can write only to their own S3 bucket, and we use EMR FS along with IAM policies for authorization and authentication. The next use case of our EMR is persistent use case, which we use for exploratory. These are the queries which users run on the EMR to generate insights on a secured environment. The users communicate via various data access layers. They can connect to EdgeNote, Alation, Tableau, SageMaker. EdgeNote is used as a gateway node to connect to EMR. We also use Alation as a data catalog mechanism, and we can run the Hive queries. Similarly, we use SageMaker. All of these EMR have access to S3 bucket, and they can write to individual S3 bucket for their sandbox. The next use case of our EMR is transient in nature, whereby we create an EMR, transit EMR, we run the job, and once the job is processed, we terminate the EMR, resulting in saving cost. So with that, going back to our journey map, our platform was ready. We have all the use cases identified. We architected it. How to support the platform? In this part of presentation, I'm going to talk about some of the initiatives we have taken for platform operationalization. The first is provisioning of EMRs. We have a number of AWS accounts, and each account we can provision n number of EMRs. So we wanted a cookie cutter method to provision the EMR based on the learnings what we had from our sandboxes. Hence, we had a provisioning tool created, which we're going to give a demo in the upcoming session. Users can communicate via API, or they can communicate via user interface, which triggers a Lambda function. The Lambda function provisioning the EMR. The catalog information is persisted, and we save the metadata in the DynamoDB. We use service catalog to persist all the required AWS configurations. The Lambda can trigger the monitoring hooks and send notification to CloudWatch or SNS topic for alerting and monitoring. Similarly, we use step function to trigger the job by Jenkins in case we want to provision EMR manually. This tool is called Quick Fabric, and we'll show a demo in the next few upcoming session. In order to provision these EMRs, we package it, whereby the developers can check in the code into Git, and we use serverless framework, which creates and deploy all the required packages for this EMR. The next in the operational bucket is tagging. We use tagging heavily in our entire infrastructure. We use tag for EMR identification. We use tag to determine the owner of the EMR. Based on tag, we're able to do a blast update on the EC2 configurations. Similarly, we use tag to identify the cost of our EMRs. The next in this bucket is AMR rotation. We do security patches as soon as we receive the latest and greatest AMI. Since we have n number of EMRs, we need to rotate the EMI and apply the patches on the EMR. Hence, we wrote the blue-green deployment AMI rotation ability, whereby with single click of a button, we are able to do the AMI rotation. Going back to our usages, we use reserved instance in our entire fleet of AWS. Here is a bar chart which indicates from May to August how we were trending. Since using the auto-scaling policies, we are pretty much consistent in our number of nodes we are using on our EMR. If I lay on cost on top of it, we'll see a sharp increase in the month of August time frame. The reason being is because many of our jobs are Spark jobs which are more memory intensive. Hence, we had to go to a larger instance type. We see the cost increase with the scale, but after that, it's pretty static. Going back to our learnings. Our first learning is usage of instance type. Second learning, monitoring and alerting. We use monitoring and alerting for our fabric layer, for our entire pipelines, and communicate via Slack messages, PagerDuty with the right escalation policy in case the delays in SLA. Auto-scaling policies, time-based or resource-based. These are based on learnings we had from our benchmarking. Similarly, we use tagging and IAM access policies to make sure we have entire right authorization and authentication in all our AWS infrastructure. And finally, we have invested heavily on operationalization and cost management. With this, I'm going to hand over to our engineers, Khilawar Verma and Naveen Soni. They're going to go over some of the use cases we have developed in this area.
Hello, everyone. My name is Naveen Soni. I'm from Intoit, a data engineer and small business group.
Hello, everyone. My name is Khilawar Verma. I am also data engineer from a small business group at Intoit.
So while Khilawar is setting up laptop for the demo, let me set up the agenda. So once we are done with the migration, there were still different issues or challenges with regards of the large-scale platform in terms of its management and operations. How are we going to deal with the EMR cluster management, the complete life cycle of the EMR, monitoring, reporting, costs, and above all, how are you going to make our users self-cert to address these challenges? So this demo is to showcase a very robust product we built leveraging several AWS offerings, and we named it Quick Fabric. In this demo, we are going to cover top 8 features of this tool under the 2 different buckets, which is orchestration and the observability. So let's quickly get started with the orchestration layer, how we provision the clusters with this tool. So provisioning a cluster is very easy 5-step process. You choose the type of cluster you need, which could be exploratory, a schedule, a transient cluster, and subtype could be either it could be Kerberized or a non-Kerberized cluster. The attraction on this tab is the AWS Account ID, which is a drop-down menu listing few AWS accounts ID. Today, AWS have some limitations where it does not provide any wrapper console where you can control multiple AWS accounts, where you can manage your EMRs from the single pane of glass. We built this capability in this tool where you can manage all these clusters in the different AWS accounts from the same UI. You don't need to bother about jumping on the different console and different browsers. Choosing the instance type. The list you see is not just a random list of the instance type for your cluster. We carefully picked up these instance type during our benchmark shadow testing results to get the best and optimum performance on the cluster, which you saw in the earlier slides. Coming to the next step, the EBS volume size is nothing but a temporary location to store your temp data while your data is being processed. Add step is an identical feature what you have on the AWS. which allows you to run some additional scripts on your cluster. It could be you want to make any changes on your cluster, your default configuration, or you want to run any jobs or Hive jobs or Spark jobs, which you can run from this add steps. If you don't have any during the cluster creation process, you can simply skip it. But it allows you as well, once you are done with the cluster creation process, you still can run the add step later on. Now, you have a chance to review all your parameters. If you think everything looks good, or if you want to hop around, you still have a chance to hop around and make some changes on the configurations. You hit the cluster create button. It asks you to submit a Jira ID. So we attached the change management process as well. So once you have your approved Jira ID or ticket ID, then you can submit it, and then its cluster creation kicked in, and then entire life cycle of the cluster start from the, but it just a series of the API call gets triggered. And within a few seconds, you have your clusters ready and will be available on the dashboard. Once this is ready, so right now what exactly is running in the behind, okay, I would skip that part, but we have the series of the API calls on the framework which runs in the background, which triggers the entire cluster creation process through service catalog and the entire cloud formation stack. As you see, it's initiating status, and if you want to see the progress or the workflow, which can be easily seen from on the console, where exactly your cluster, in which state your cluster is in. So as you see, so this is the first scenario of this tool where the cluster creation process we made it very easy. You don't need to worry about what VPC you need to select, what subnet you need to attach, what security group you want to attach with your cluster. You don't need to worry about anything. So it provides us from the single pane of glass, you can manage all those activities. Let's quickly jump on the second scenario, which is a testing framework attached with this tool. So once your cluster is ready, you wanted to make sure that your cluster is ready and you can push it into the production. How do you do that? Without having any verification test or sanity check, you're not sure about that. So we built this capability in this tool where we just included 4 to 5 different test scenarios, and once those scenarios are completed and checked and performed, then you can be a peace of mind where you can push your cluster into the production. Getting started with the auto-scaling policy. How do we make sure that auto-scaling policy is attached with your cluster? What is the minimum or max value on those auto-scaling policies? Number of bootstrap actions, number of add step actions you executed on the cluster. Were all those scripts executed successfully or not? The connectivity test, a very important test. Tools like Beeline or PySpark, Spark Submit, you might have on your jump box on your local machine. We included that capability as well, so it can go on the jump box and try to trigger a simple select statement to make sure that connectivity is true, and you should be able to connect through your tools on the cluster, on newly created clusters. It also sent out an email notification about the status of all these different tests under this testing framework. So that completes the scenario number 2 at the feature 2. Let's quickly jump on the AMI rotation, which is a very interesting feature we included in this tool. Imagine you have multiple AWS accounts and n number of clusters running into those accounts, and you want to rotate or you want to rebuild those clusters with the latest AMI available in your account. How do you do that? There is a challenge if you do it with manually on the scripts in one account at a time. You can think of how much time you can invest into this particular activity. But we made this activities very seamless with one single click button. All you need to do is just select the cluster you want to rotate, choose the name and confirm it, we want to rotate it. If you want to push this cluster into the production, once all the testing framework which we saw are passed, it will automatically push your cluster into the production. If anything fails, it will tell you right away that things are failed and it will send you the email as well. As you can see, there's an auto DNS flip option that performs that DNS flip activity. Once you are sure, then you can just submit the button, and it will just trigger the entire process of creating the cluster, provisioning the cluster, running the test suites, and pushing it into the production. So that concludes the feature number 3 from the orchestration layer. And we also included another feature up here, which is an automated AMI rotations. Suppose if you want to rotate those clusters every 30 days or 60 days. So there's a schedule running in the behind the scene where you can configure it in how many number of days you want to rotate those clusters. If you want to push them into the production, that will automatically do the job, and you receive an email upon successful completion. After that, Clover is going to cover the observability part.
Thank you, Naveen. Thanks for giving the information about orchestration. So in this part of the demo, we are going to see 5 important features about observability of EMR, which we have built in Quick Fabric tool. This is the first screen for the observability. Of course, we will talk about it in detail, but let me give you one small scenario. Hopefully, many of you would have seen this is one of the UI given by AWS as part of the resource manager for particular EMR, which gives some information about your EMR health and all. So you will be wondering, since we have some shape or form of the data for your EMR, why we have built the observability part of it. I can give you a few options why it was required. So this is one of the EMR we are talking about running in one of the account. And we have seen in previous slides, we have multiple accounts, multiple EMR clusters, and thousands of jobs are running in these EMRs at any given point of time. And we are talking about only just this matrix. We will have many more metrics which we need to gather to find out what's going on in your EMR, like cost, historical data, job scheduling window, etc. So when you compare all those scenarios together, I don't think this screen will be sufficient, right? And so for that, we have built this UI, which actually compares and offload all your complex and manual gathering data process behind the scene by this tool and present it here in a very nice and neat UI. That was the feature number 1 from observability. Let's talk about feature number 2, user persona. User persona actually is very important to understand because some set of users, they look for, maybe some Uber picture, how my cluster is performing or is it up or not. But some other set of users, they look for detailed view of your data about your clusters for their debugging purposes. So in order to satisfy all different kind of users, we have to understand the user persona concept, and let's see how we have built that to make sure all types of users are able to get their data here. First user persona comes from the analyst users. These types of user actually look for the Uber picture, like why their cluster is healthy, some types of jobs are running or not. So if you see, we have given some color coding that these clusters are healthy and they are kind of empty, nothing is running, so you can run your jobs. Some clusters are in running mode, which means at this particular point of time, some jobs are actually being executed. We have also given some kind of filtering options, like some user comes and they say, I only want to see marketing type of cluster. We can filter it here and see the data, right? So we are kind of able to satisfy that user persona. The second set of user persona, data leaders. And I think many of you would have understood that data leaders are actually very, very particular about cost. So every time my leader comes to me and asks, Kilav, what's going on? Why my cost is high and where the cost projection going on, so on and so forth. So many questions every day at 6 o'clock. So what we thought, let's actually solve this problem once for all for those kind of users. So what we have done, as we have seen that the whole tool is a click button functionality. So we have given one button here, which will actually project the cost for all those clusters in that particular month. Of course, you can see, button click is easy to see, but behind the scene, we have to do a lot of work to get this data, because getting AWS cost is not easy for EMR. A lot of components are involved into that. Now, let's move on to the third persona, data engineers and SRE persona. These users, they actually look for the over picture of their cluster, but they also want more data for their debugging purpose, because they are the users who actually support your clusters. So what we have done to satisfy them, they can, let's say, want to see what's going on into this particular cluster. You can come inside this cluster, and you can see we have given the first section about the duration, because we have to show them the historical data in case they want to debug some problem and want to know whether this issue is new issue or it's a recurring issue. And unless you have historical data, you can't find that. The second section gives the different tabs about the data of that particular cluster. We'll see that. Let's say I want to see in this particular cluster what's going on in last 1 day. So the first tab is cluster detail, and the first value is business owner. Business owner is very critical component, because if something is wrong in this cluster and we want to change something, right, you want to get an approval from business owner, and you don't need to find out who to reach, right? You can easily get the information from here. And we have also given some other information like hardware, how much is the capacity for the cluster, what is the mode of it right now, which account it is running, and which RM URL, and so on and so forth. The second part is very interesting. I want to know in last 1 day how many jobs were completed or were pending. Some of them were failed, so on and so forth, every hour. So we have built a very nice graphical representation for 24-hour to show about the job status in various states. We also have a tabular format in case somebody wants to see the average data. The third is a system stat. We have seen the job detail, but we also want to know how this particular cluster performed in terms of memory and cores, right? So based on that, we can get an idea whether we need this big cluster or not, or we need to increase the capacity of the cluster. So you can see, we have like 75% of the cluster size is empty. So maybe you have an option to reduce the size of the cluster. So this also, there is one very important metrics, user want to know what is going on currently in the system at this moment. So when they come and click here, they can see that one job is being executed by Hive user, and it has captured 99% of the resource of your cluster, which means if somebody wants to run a job right now, they have to wait. It will be actually queued, so they can get this information immediately right there. Because somebody says, oh, my job is actually not being executed. So the SRE team can immediately, or actually the person itself can come and see here that, yes, because the jobs, the cluster size utilization is 100% right now, which is occupied by one job, your job will be queued and it will take some time. So, you don't need to worry about that, and after some time, it will be executed automatically. Some users, they don't want to see this, graphical representation. They are very good into tabular format. We are covering them as well, and we are showing in a tabular format for them as well. So now we covered the user persona. Now let's move on to third important feature, business insights. And that feature right now is not available anywhere in terms of EMR in any of the systems. Because you need lot of information to give some advice or to generate some business insights. So let's see how we are doing that. Let's say I want to again come here and click this window. I want to know what is the right window for my new job to schedule in this particular cluster, right? So what we have done, we have written algorithm behind the scene which captures the job scheduling window and also your job stats, compares them, and give you suggestion that if you run, let's say, least 3 utilized hour of your cluster, so that you can get better performance and ultimately you can save the cost. We have also extended the advice by integrating the Dr. Elephant, which is an open source expert advice tool for EMR, which basically gives you various knobs and tuning parameters to increase the efficiency of your job by following some of the advices, which concludes the third feature. Now, let us move on to number 4. Any observability tool is not complete without notification and monitoring, and without notification and alerting and reporting. We have covered that as well. So, we are generating the data and the report behind the scene and showing in an email and in Slack integration to the users and to admins of this tool to know how my cluster is performing last 1 day, 1 week, 1 month in terms of cost, job execution, system stats, and very important, if my cluster is violating any AMI rotation policy, right. So, we have generated some test data just to represent the view here. These are the testing data just to show the color coding, that some of my clusters are actually violating the AMI rotation policy. So, it can actually come immediately to the management attention that we have to fix this issue immediately. You can see we have shown almost 30 clusters, but some users say I want only my cluster, why I need to see these many records. So, we have done the personalization of those reporting as well, that if I have created a cluster for marketing, I will only get this report, so that I can only worry about this particular cluster. Now, let us move on to the number 5 feature. This feature is actually more concentrated towards the development of this tool. So, when we were developing it, we always made sure that we have to follow best industry practices, proper coding styles, making sure that we are using latest and greatest technology with latest versions. We should be using API driven model. We have SSO integration, we have access control, we have logging and exception common exception models, which can allow user to develop 50% faster using this framework. Are we done yet? Of course not. We have made this tool as a cookie cutter design pattern, which can be easily applied to any other big data infrastructures, like if you want to integrate Redshift or Athena or any other big data tool into this framework, it can be easily done with 50% better development performance from the development side. But is it enough? Of course not. Since we have done some interesting work here, we thought of sharing the love with the community, and we are highly excited to open source this tool in very near future. So, this concludes the 5 features from observability point of view of the EMR. Now, I will invite Sandeep to go over the next part of the session. Thank you.
Fantastic. So, now with Quick Fabric, you can move to EMR as quickly as you want. So, just to wrap up, so far we've talked a lot about technology, right? And just to summarize the high points here, there are multiple EMR clusters that we are running as a part of this deployment, and some of the specific respect to Hive on Tez compared to more of the Hive on MapReduce/Spark that we were using on-prem. I want to sort of end with a few key points. Now, we talked about technology, an equally important part is users. How do you move your users to a different platform? And in our journey, we had hundreds of critical dashboards and jobs owned by analysts and data scientists that had to migrate. And anytime you think about migration, there is a validation with respect to correctness of results. Towards that, we had to run this as a very tight program where we had the notion of support buddies. So analysts and data scientists were grouped together in small, think of these as Scrum teams or pizza teams, whatever is your preference there, with infrastructure engineers, data engineers, ETL engineers working hand in hand. So that was one sort of secret recipe in terms of breaking hundreds of these into smaller groups based on business domain and combining the users with the engineers, making the deliverable of validation and ensuring that what's running on cloud matches exactly what's on-prem. The other equally important part with respect to users is runbooks. Imagine these are fundamentally new journey maps that the users have to accommodate. And having that clarity upfront, investing upfront in building these runbooks pays off significantly. This is one of the key reasons we were able to expedite and complete this in a relatively shorter time frame. And the last bit is training. I think I cannot emphasize enough here, and this is the part where when you think about training, it's not just the generic understanding of what EMR and what the cloud is, but specifically how does the journey map for the users look like before on-prem and after in AWS. Having that clarity, again, is extremely important. So with this, I just want to quickly talk about where we are today, given that we have completed migration and it's been more than 6 months where we are. So to highlight some of the advantages we have seen, one is definitely isolation across business units. On-prem, we were constantly in the tussle across different business domains, each wanting their jobs to given the highest priority. That's not the issue anymore. These are independent EMR clusters, independently scalable, so on and so forth. Managed infrastructure, our engineers are able to sleep better tonight. We are able to sleep better tonight. A lot of the infrastructure issues are non-existent. The focus is more with respect to pipelines and jobs rather than the absolute node failures and the fundamentals there. Availability has been extremely good ever since we've migrated. From a cost standpoint, initially we started with the wild, wild west in terms of cost, but very quickly you start bounding yourself with respect to having a well-defined configuration, a well-defined set of jobs. So I would basically say from where we are right now, essentially we can benefits of cost are visible. And last but not the least is the self-serve aspects. We are able to unlock the end data users to go ahead and deploy. So using tools like Quick Fabric, you can actually see one-click deployment, one-click experimentation. So that has been phenomenal in taking the load away from the platform team. I always like to look at things as a scorecard. And this overall journey for us, the success essentially had a few dimensions. So the first aspect was with all the tools and automation that was built, we were able to move 400 plus most business critical dashboards in less than 16 days. I think that was, we were surprised as well because with all the preparation and pieces in place, that was actually possible. Second is making sure that all the users move, which has happened quite seamlessly. On an average, we see improvements and just conservatively 60 to 90 minutes improvements for all our critical dashboards. And again, this is a very conservative numbers. And finally, the self-serve part. Today, we have several of our users who are very excited by the fact that they can accomplish things without getting blocked and really unleashing the power of the cloud. So what's next for us? Obviously, we continue to enhance our deployment. Self-serve is something we are looking into or focusing heavily on. Query virtualization, especially as we adopt a broad range, all the way from Redshift to Redshift, Athena, and in the EMR, you both have Hive and Spark, along with Flink on the horizon. We're looking into transient EMRs in sort of adding them to the set of things we do. And open source is something which we want to, or we'll be working towards in the coming weeks with respect to taking most of the things you saw in the demo and making them available. So with that, I'd like to thank quite a few teams here, both within Intuit that we work with, as well as the AWS team. I think we've been fortunate to have some of the best engineers, product managers, program managers work with us. So it takes a village when you think about efforts like this. With that, I'll be open for questions, and I'll call in all the other participants as well. Thank you.